as I said, divisibility should be a somewhat familiar property that we're talking about here, where the easiest way to understand the idea of divisibility, whether or not a number divides another number, what the factors are. Again, there are definitions for that, where we say that two numbers multiplied together to get a third are factors, and so those numbers divide the original, but really it's easier to understand all of this stuff with a very basic example, where we could say that because 2 times 3 equals 6, we would call 2 and 3 factors of 6. They're essentially smaller numbers, smaller pieces that you can multiply together to get something else. Where, to be clear though, 2 and 3 being factors doesn't mean they're the only factors, and it also doesn't mean that if we take other factors, they have to multiply in the same way. For example, in this context, 1 and 6 are also factors of 6 because 1 times 6 equals 6, but it doesn't quite throw things off that 2 times 6, or 3 times 6 for that matter, are not, obviously, 6. It's just a matter of having some values in here that can be thought of as pieces, where we can also say that if these values are factors, then they further divide the larger number. That 3 divides 6, and 2 divides 6, or in other words, if you want to turn the implication, as it were, of the wording around, you could say that 6 is divisible by 2, or 3, or 6, or 1 for that matter. And we have that special notation there where we put the smaller one, a vertical bar, and the bigger one, where this is read as 3 divides 6, or 2 divides 6. And that direction is important. For example, if we tried to flip it, we would not have that 6 divides 2, so we draw a diagonal line through the vertical line to say that 6 does not divide 2. That's how this is read. Does not divide 2. And then similarly, we could also look at something like whether or not 5 divides 6, where because 5 is not a factor of 6, well, that's how we would say that. And in more general cases, we have some quick rules that we can use for determining divisibility, especially with the small values. I'm just going to go through quickly here so we can get some understanding of that. Where if you want to check if something is divisible by 2, we just basically have to see if its last term is an even number. Say, for example, we have 5,892,796. It might be hard to figure out what that would be divided by 2, but because it ends in 6, it is even, so 2 divides it. For 3, we want to see if the sum of the digits is divisible by 3. Then for 4, if the last 2 digits form a number divisible by 4, you can also maybe quickly check this if it's divisible by 2 twice, but check those last 2 digits and you'll have the same idea. For 5, see if it's 5 or 0. For 6, you have to check if it's divisible by both 2 and 3, which is pretty quick, because obviously you need it to be in there in such a way that both divide there, otherwise it can't be divisible by 6. Then at 8, the last 3 digits have to form a number that is divisible by 8, so it's kind of like you're continuing up with powers of 2 there. For 9, you want the sum to be divisible by 9. For 10, the last digit has to be 0 for hopefully obvious reasons. And then for 12, you need both 3 and 4. Where I'll say that there are other things you can track around for other special ones, but a few just aren't that nice. Like 7, for example, is usually a bit of a sticky value to work around. You have a nice trick for noting divisibility by 7, because 7 honestly just isn't a very convenient value, and base 10 generally, to think of it in the language of our last section. Where I should also say that a lot of these things, they're kind of making the assumption, a reasonable assumption, that we're always thinking in terms of base 10. We're not adding that extra layer of complexity to wonder if 3 divides 6 as well in, say, base 4. Because, well, 6 isn't a thing in base 4, but don't worry about that. That's the point. Anyway, when we're talking about divisibility, we're talking about factors. The most obvious factors that we can work with are the smallest ones, things like 2 and 3, and other pieces we can pull apart with a behavior like that, where these types of numbers that we want to work with are often what end up being prime numbers, and then we can talk about how we can break apart our non-primes or composite numbers into primes using a process called prime factorization that we'll be looking at next.